Molecules with expanded octets. Atoms in period 3 can expand their octets by utilizing the 3d orbitals for bonding. Common examples include phosphorus, fluorine, chlorine, bromine, and sulfur. We will look at species with 5 and 6 negative charge centers. A single, double, or triple bond and a lone pair of electrons all count as one negative charge center. So we'll start with 5 negative charge centers. So in this first example, we have 5 bonding pairs of electrons. We have 0 lone pairs of electrons. The shape is trigonal bipyramidal. The bond angles are 90, 120, and 180 degrees. And the example we have here is PCl5. In PCl5, we have phosphorus as the central atom. It's expanded its octet, and it now is forming 5 single covalent bonds with the chlorine atoms. So next, we're still on 5 negative charge centers, but this time we have 4 bonding pairs of electrons and 1 lone pair of electrons. The shape is seesaw, and the bond angles are 90 degrees, and this means less than 120 degrees. And the example we have here is SF4. So here we have the SF4 molecule. Sulfur is the central atom, and it's bonded by single covalent bonds to 4 fluorine atoms. And we also have this lone pair of electrons here, and because this is repelling the other bonds within the molecule, we have this bond angle of slightly less than 120 degrees. So next, 5 negative charge centers, 3 bonding pairs of electrons, 2 lone pairs of electrons. The shape is T-shaped. The bond angle is less than 90 degrees, and the example we have here is ClF3. So here we have the ClF3 molecule. We have the chlorine atom as the central atom, and it's bonded to 3 other fluorine atoms. And we have 2 lone pairs of electrons on the chlorine atom, and these lone pairs, the repulsion between these lone pairs and the bonding pairs of electrons, this is the reason for this bond angle being slightly less than 90 degrees. So next is the final molecule for 5 negative charge centers. We have 2 bonding pairs, 3 lone pairs. The shape is linear. The bond angle is 180 degrees, and this example is XeF2. So here's our XeF2 molecule. Xenon is the central atom, and it's bonded to 2 fluorine atoms. We have 3 lone pairs of electrons around the xenon atom, and this results in a bond angle of 180 degrees. So now moving on to 6 negative charge centers. In this example, we have 6 bonding pairs of electrons, 0 lone pairs of electrons. The shape is octahedral. The bond angles are 90 degrees and 180 degrees, and this example is SF6. So here's our SF6 molecule. The central atom is the sulfur atom, and it's bonded by single covalent bonds to 6 other fluorine atoms. 6 negative charge centers, but this time we have 5 bonding pairs of electrons and 1 lone pair of electrons. The shape is square pyramidal. The bond angles are less than 90 degrees and 180 degrees, and this example is BRF5. So here's our BRF5 molecule. We have bromine as the central atom, and it's bonded by single covalent bonds to 5 fluorine atoms. We also have this lone pair of electrons here, which repels the bonding pairs of electrons, so we have this bond angle of slightly less than 90 degrees. So this is our final molecule for 6 negative charge centers. We have 4 bonding pairs of electrons, 2 lone pairs of electrons. The shape is square planar. The bond angles are 90 degrees and 180 degrees, and the example is XeF4. So here's our XeF4 molecule. The xenon atom is at the center, and we have single covalent bonds to 4 other fluorine atoms. We have 2 lone pairs of electrons on the xenon atom, and this gives us bond angles of 90 degrees and 180 degrees. And finally, we have a summary. This is the table of bond angles for high level. We have the number of negative charge centers, the number of bonding pairs, number of lone pairs, the shape, the bond angle, and an example.